Hey guys, Mr. Bowman here. Today's learning objective is in yellow and we are learning to rotate an object by given instructions to create an image. So I suppose the key word to focus on is rotate, and this video is going to be all about rotations. And before we get on, there's a few concepts we need to go through and then we'll get into some examples. So every rotation, you need to know, well, which direction is going to happen. So what's the direction of rotation? And just using the one on the screen as an example, we could rotate it to the left, which would be counterclockwise. So we've got counterclockwise. Oh, sorry, that actually is clockwise. And we have the alternative counterclockwise there. So it's one of those two there, counterclockwise or clockwise. The next thing we need to know, we do need to know about the angle of rotation. So that's measured in degrees, and that's basically how far we're rotating it. So do we stop here? Do we carry on, go a bit further? Do we carry on even more and do 180? So there's a whole bunch of different options for that. But for most of the examples we're going to do, they're going to be limited to 90 degrees or 180 degrees. And I'll explain why it's 90 degrees as well. And the final one is we need to know the center of rotation. So normally, or a lot of questions, it'll be the origin that uses the center of rotation, but that's not always going to be correct. It could be any point on our X and Y axes. And normally those center of rotation, they are done in coordinate form. All right. I suppose the first step we want to focus on is that why 90 degrees? So what happens is, so let's say we rotate this shape here 90 degrees. So that would end up here. That would actually be the same as a 270 degree rotation ending up here. So we could say 90 degrees clockwise, or we could say 270 degrees anti or counter clockwise. But when we're going through this approach, just note it's customary to describe it with reference to the smaller angle. So that's why we'll never really refer to 270 degrees, because that's the same as 90 degrees in the opposite direction. So we'll rub all of that out. And what we're going to do is we're going to start off with an example, and I'm going to switch to the blue pen just to differentiate our work. So in this blue example, we're going to rotate. It's going to be 90 degrees, and we're going to go clockwise, and we're going to go around point -1, 1. So we've got our 3 bits of information. We've got the angle of rotation, we've got the direction of rotation, and we've got the center of rotation. And that's enough to do any rotation question. So let's get rid of all that. So first step, let's label all the corners of our triangle, because that's a big help when we're doing these questions. So that there's going to be A, down here is B, and down the bottom is C. We're also going to label the center of rotation, which is -1, 1, which will go up there. And we can then start to draw reference lines. So what I like to do is I like to draw kind of the quadrants from the earlier video that breaks things up into its 90-degree segments. So what we can do is we can see 90 degrees. And what we know is this point C, well, this point C is going to be rotating 90 degrees as well. So that means this point down the bottom, well, that's going to be our C prime. And if we go across by 4 boxes, which is 2 units, so we can go the same here, across by that. That's going to get us in line with A, and then we're going to go across 3 boxes to get to there. So 1, 2, 3, and that'll get us to A dash. And then we repeat the same for B. We'll just be able to use rough measurements. So from C, it goes 6 units up. So let's go 1, 2, 3, 4, 5, 6. And that there would be B prime. From those points, that gives us our shape. And that there would be our rotated triangle, or that there would be our image. Another way to say it. So I won't color it all in. There we go. So there's a lot of little things to them. Key thing to note, the orientation is going upwards, and when we rotate it, it tips on its side and the orientation changes direction. So our triangle is now pointing out here. So let's give it another go. Let's rotate this 180 degrees. And we're going to use -2, 0 as our point of, or our center of rotation. So we'll change pen colors just to make this a bit easier. Let's go to green. So we're now working with these two instructions here. The key thing to note regarding the 180 degrees, if we go clockwise or counterclockwise or clockwise, it will end up in the same position. So for these ones, we don't actually have a direction of rotation. So let's do the same thing. So it ends up 90 degrees in this quadrant, which means 180 degrees is going to end us up in this quadrant here. So we're going to need to use all of that information to figure out where exactly it ends up. And the key thing is, we'll start off with our same reference points. Well, 80 degrees, so 90 degrees got us to C dash. And if we do 180 degrees, that there is going to get us to C, we'll call it dash dash. So our second prime, or our second shape. And the same thing is, so what we're doing is we're now flipped upside down. Before we followed our triangle to find A, so let's use that. So we did that up here. So we're going to go down 4 boxes. So we're going to go 1, 2, 3, 4. And from there, we're going to go across 3. 1, 2, 3. And that there would be the equivalent of A dash dash. And using kind of the symmetrical nature of our shape, we'll be able to plot and find B dash dash as well, which would be about there as well. B dash dash. And then from there, we've got our triangle. And what we can see is its original orientation is up. Makes sense, 180 degree rotation. It's now pointing down. I suppose the next question is, how would we describe in words these rotations? So we'll switch to the blue pen and we'll describe that blue translation. So we just kind of put it in key points here, but let's put it in sentences. So we're going to write the yellow triangle was rotated, because that's the transformation we're looking at, rotated 90 degrees clockwise around point -1, 1 to create the blue triangle. And I'm just going to use a highlighting function. You'll be able to see we've got the transformation, we've got the angle of rotation 90 degrees, we've got the direction of rotation, and we've also got the center of rotation. So it's got all of those parts that we need. So we'll switch to the green pen and we'll describe that last translation in green. So again, the yellow triangle was rotated, because that's the transformation we're doing, 180 degrees. And here, doesn't matter which direction it goes, because it's going to end up being the same, around 2, 0 to create the green triangle. And that would describe that one there. And again, stepping through that, we've got the transformation, which is rotation. We've got the angle of rotation, 180 degrees. As I said before, we don't need a direction for this example. And then finally, we've got the center of rotation around 0.2, 0. Sorry, that should be -2, 0 as well. So hopefully you found this video useful. Okay, we've cleared up working. The final bit to this video is finding the points of rotation. And we've got our object in yellow and our image in grey. And the first thing we want to do is we kind of want to pair up corresponding corners of our shape. And what we want to do is we want to perfectly connect those with a straight line. Hopefully your ones are a bit better than what I'm doing by hand on my computer. Once we've done that, we then want to repeat that same process. There's our red dot, and there's the corresponding point down the bottom. And same process. And again, hopefully yours is looking better than mine. We just want to connect those with that line. And from here, we want to draw perpendicular lines. And they are lines, if that's our line there, they are lines which are right angles to the existing line. So we're going to give that a go. So our drawing won't quite be perfect because it's not by hand, but we'll give it a go. So I don't know, something along those lines looks a bit perpendicular to me. So let's carry that on before and carry that on after. And those look like right angles to me. So I'm happy with that. Let's do the same with the green line. I don't know. Oh, that's not quite right. But maybe something on more of an angle. Maybe about there. They look like right angles to me as well. So let's extend that either way. So draw down and we draw that up there. So the two perpendicular lines, I'm just going to label them P. The intersection between those lines, which is right down the bottom there, that is roughly going to be the point of intersection. So mine might be slightly off because of the drawing by hand, but yours should be more accurate in your books. But it does look right. And the way I like to test it is I like to see, are they the same distance away? So in our case, it's 1, 2, 3, 4, 5, 6, 7 boxes away. And let's check the other side. 1, 2, 3, 4, 5, 6, 7. Perfect. So both 7 boxes away. They both have the same position with reference to the shape. In that case, they both hit directly in the middle. And in our case, by using perpendicular lines, we've been able to find, so perpendicular lines, we've been able to find the point of rotation for this shape. So guys, this is going to wrap up today's video. Hopefully you found it video. Make sure you get down all your notes and let's get into heaps of practice. Now let's get into heaps of practice.